Hello everyone. So this is one good question on analog electronics. So you have to find the 3 dB bandwidth and you are given some certain value. GM by GDS is 9, R 10 kilo ohms, C1 C2 values. Okay. So now you have to find that 3 dB bandwidth. So what you can do from this point to this point, we know the gain, right? From this point to this point, if there is some voltage, one small signal voltage applied at gate voltage, we know what would be the gain at drain voltage, right? So the gain is Gm R naught upon Gm R naught plus 1, right, for common drain configuration. Not at drain, at source. Okay, like this is common drain configuration. We have some input applied at gate terminal, so at output we know what is the gain. This is Gm R naught upon Gm R naught plus 1. So so the gain would be 9 by 10. So from here to here we have 9 by 10 gain. So for this capacitor we can apply Miller's theorem, right? This is Miller's cap, right? So what we can do, this is R. If we do small signal analysis, VDD would be shorted, so this C1 would come here, and now this C2 would come, C2 into 1 minus 9 by 10, it would be C2 by 10, and this is R, this is V in. Now we have MOS here, MOS circuit here, this MOS circuit here, this is ground, and here we are calculating V output value, and we have some finite resistance as well, right? Some finite R naught resistance as well, and here we have one 3 dB frequency, and here this capacitance, and at V output also we will have some capacitance. So I need to draw the circuit on next page. Yes. So this would be your final circuit, right? Okay, so there will be like what I did, I simply applied Miller's cap here. So this C2 would be 0.1 into C2, so it would be 0.1 picofarad, 0.1 picofarad, R equals to 10 kilo ohm, and here at this side, at V outside, we will have C2 into 1 upon 1 by AV, this value we will have. So it would be 1 upon 1 minus 10 by 9, so it would be minus 1 by 9 into 10, so it would be minus 10 by 9 picofarad. So here you will have two frequency component, one is this one and one is this one. Look here, you are not having any R naught value or anything given, right? So this would be the component that would be useful in finding the 3 dB bandwidth. Okay, so what would be the 3 dB bandwidth here? So bandwidth would be 1 upon 10k into 0.2 picofarad. So it would be around 5k and 5k into 10 to the power, let me show. So the answer is 500 mega radian per second. Okay, let me repeat once again. This is the question, these are the value, you have to find the 3 dB bandwidth. What you did, you applied the Miller's cap from here to here. Okay, so you applied the Miller's cap, so this was your final circuit. So this would be the component that would result in 3 dB bandwidth. So 10k, 0.1 picofarad, 0.1 picofarad, 0.2 picofarad, 10k into 0.2 picofarad, 50 100 mega radian per second. Okay, so this is the final answer.